Hey, today we're covering batteries on things you don't know. We're going to talk about who invented them, why they mattered, the main kinds of batteries, because we get into tons of different kinds, but we're going to get into the main ones, and how they changed ordinary life by making electricity portable.
Before batteries, electricity was mostly something scientists produced briefly with static machines. It could make sparks, it could shock people, it could be demonstrated in a lecture hall, but it was not yet a steady, useful source of power.
So the key change was not simply discovering electricity. People already knew about electrical effects. The big change here was finding a way to store chemical energy and turn it into electrical energy on demand.
The story begins with a debate in the late 1700s. Luigi Galvani, an Italian physician and scientist who noticed that frog legs twitched when touched by metal under certain conditions. He believed the movement came from what he called animal electricity.
Dr. Weaver, that idea was important because it suggested electricity might be connected to life in the nervous system. Galvani was not foolish. Nerves and muscles do use electrical signals, but his explanation did not fully account for what was happening in the experiment.
Alessandro Volta, another Italian scientist, disagreed. Volta believed the electricity came from contact between two different metals, with moisture or fluid helping complete the circuit. He didn't think the frog was the source of the electricity.
Right. And Chandler, a lot of people get that wrong. What you said is very correct. That disagreement pushed Volta toward one of the most important inventions in electrical history. Around 1800, he created the voltaic pile. It was made by stacking pairs of metal discs, usually zinc and copper or silver, with pieces of cloth or cardboard soaked in salt water between them.
That stack produced a steady electrical current. It was not powerful by modern standards, but it was revolutionary. For the first time, scientists had a source of continuous electricity that could be used for experiments.
So the first true battery was not invented to run a flashlight or a phone. No, it was invented to prove a scientific point and to create a steady current for investigation.
Yeah, the voltaic pile changed what scientists could do. Static electricity came in brief bursts. A battery made electricity available in a controlled way. That opened the door to electrochemistry, electromagnetism, telegraphy, and later electric motors.
It also gave us the word volt, named after Volta. That tells us how central his work became. A volt measures electrical potential, or the push that moves electrical charge through a circuit.
That's right, and the early battery was not very practical. It leaked. It could give off gases. The voltage could drop even. But even with these problems, it changed the entire field because electricity no longer had to be a momentary demonstration.
The next major improvement came in 1836 with the Daniell cell, invented by John Frederick Daniell. It used copper and zinc in separate solutions. That design reduced some of the instability found in earlier batteries.
Yeah, the Daniell cell became important because it produced a steadier current that made it useful for telegraph systems, which needed reliable power over long periods.
Dr. Weaver, that is a major step in the story here. Batteries moved from scientific instruments into communication technology. The telegraph needed electricity, and batteries helped supply it. even before large power grids existed.
Chandler, what you're saying is right. Can you imagine if we didn't have the telegraph back in the early days? I know Dr. Deneen could talk to us for about 4 hours about the difference that the telegraph made. It was a mass communication thing that was critical for development.
It absolutely was, Dr. Weaver. Don't worry, I won't torture you for 4 hours.
No, but can tell you when I was in my communications classes at Emorio, Dr. Weaver, that was one of the things that we talked about and spent
Yes.
a lot of time talking about and the importance of the invention and how it flashed us forward, basically.
Well, yeah.
Yeah.
This matters historically because communication was one of the first major areas transformed by electric power. Messages that once took days or weeks could move across the wires in just a few minutes.
Yes, sir, buddy. In 1859, Gaston Pilante invented the lead acid battery. Now, this was the first rechargeable battery that was practical enough to become widely important.
Lead acid batteries are heavy, but they can deliver strong bursts of current. And that's one reason that they became so important in automobiles.
Even today, ladies and gentlemen, many gasoline powered cars still use lead acid batteries. They help start the engine, power the lights, and support electrical systems. They are also used in backup power systems, emergency lighting, and some industrial equipment.
Yeah, the weakness in these batteries is the weight and lower energy density. In simple terms, they store less energy for their size and weight than newer battery types, but they are relatively inexpensive, very rugged, and they're very well understood.
And in the 1860s, Georges Leclanche developed another important battery using zinc, manganese dioxide, and an ammonium chloride solution. This became the basis for many later household batteries.
And the original Leclanche cell still had liquid inside it, so it was not as convenient as later designs were, but it helped move batteries toward an everyday use.
Yes, the big household breakthrough was the dry cell. Now, a dry cell is not completely dry, but it uses a paste rather than a free liquid. That made batteries easier to carry, store, and use in portable devices.
By the late 1800s and early 1900s, dry cells helped power doorbells, flashlights, radios, toys, and early portable equipment. This is the time frame where batteries began entering ordinary homes.
Now, a simple way to divide up batteries is into two groups: primary and secondary.
Yes, primary batteries are meant to be used once and then replaced. Common examples include zinc carbon batteries, alkaline batteries, and some lithium metal batteries.
Now, secondary batteries are rechargeable. They can be discharged and then recharged many times. Examples include lead acid, nickel-cadmium, nickel metal hydride, and lithium-ion batteries.
And Dr. Deneen, that difference matters because each group fits different jobs. A TV remote may only need just a cheap battery that lasts a long time under light use. A phone or an electric vehicle needs a rechargeable battery because replacing it every time it runs down would be impossible and quite expensive too, I would have to say.
Alkaline batteries became one of the most common household battery types. They usually use zinc and manganese dioxide, but with an alkaline electrolyte. Sounds like gobbledygook, doesn't it?
It
But
does.
It kind of does, yeah.
Now, compared with older zinc carbon batteries, alkaline batteries usually last longer and perform better under many common conditions. That made them popular for flashlights, clocks, remote controls, radios, toys, and even small electronics.
And they're still widely used today because they are affordable, available almost everywhere, and good for devices that do not require constant, heavy power.
Yeah, that's true, but most ordinary alkaline batteries are not designed to be recharged. There are rechargeable alkaline versions, but they are not the main rechargeable battery used in modern electronics.
Nickel-cadmium batteries, often called NICD batteries, became important in the 20th century. They were rechargeable and durable. They powered tools, radios, emergency equipment, and early portable electronics.
And they also had drawbacks. Cadmium was toxic, and NICD batteries could suffer from what people often called the memory effect. And that's where repeated shallow discharge could reduce useful capacity under some conditions.
Absolutely. Well put. Nickel metal hydride batteries, or NIMH batteries, became a cleaner and higher capacity alternative for many uses. They became common in rechargeable AA and AAA batteries, cordless phones, cameras, and in hybrid vehicles too.
For a time, NIMH batteries were especially important because they filled the gap between older rechargeable batteries and the rise of lithium ion.
Yeah, let's talk a little bit more about those lithium-ion batteries. They are a battery type most associated with modern portable electronics. They're used in phones, laptops, yep, laptops, tablets, power tools, electric bicycles, electric vehicles, medical devices, drones, and many energy storage systems.
And the reason for this is energy density. Lithium ion batteries can store a lot of energy for their weight compared with many older rechargeable batteries.
The development of lithium ion batteries involved several major contributors. Stanley Whittingham worked on early lithium battery chemistry in the 1970s. John Goodenough developed a more powerful cathode material. Akira Yoshino developed a safer and commercially practical version in the 1980s.
Yeah, so it's continuing to develop. Sony commercialized lithium ion batteries in 1991, and that helped reshape consumer electronics. Phones could become much smaller, laptops could run longer. Later, electric vehicles became more practical. Really important stuff.
It is, but I have to say, as amazing as these lithium ion batteries are, Dr. Weaver, they are not perfect. No, sir. They age over time. They could be damaged by heat. If poorly made, abused, or charged incorrectly, they could become dangerous too. And that is why modern devices include battery management systems to control charging, temperature, and discharge.
It's important to remember that not every battery is designed for high power. Some are designed for tiny devices that need low power over a long time.
Yeah, button cells, they're small, flat batteries used in watches, hearing aids, calculators, medical devices, key fobs, thermometers, and even small sensors.
These batteries may use chemistries such as silver oxide, zinc air, alkaline, or lithium, depending on the device. A hearing aid needs a different performance than a car key fob does.
Zinc air batteries are especially important in hearing aids because they can provide good energy for their size. They use oxygen from the air as part of the chemical reaction.
I just think that that is amazing. just amazing that somebody could come up with that. Let's
I do
talk
too.
about, yeah, yeah. Let's talk about batteries in vehicles. Another topic area that Chandler had said we got to say some good stuff about this, and
Oh
I
yeah.
agree. Yeah, vehicles use batteries in several different ways. Traditional gasoline vehicles usually use a lead acid battery to start the engine and power electrical systems when needed.
Hybrid vehicles often use nickel metal hydride or lithium-ion batteries. These batteries help capture energy from braking and assist the engine during acceleration.
That's right. And fully electric vehicles rely on large rechargeable battery packs, usually lithium ion. Now, in this case, the battery is not just supporting the vehicle, it is the main energy source for the vehicle.
Yes, sir. And that changes the engineering problem. Designers have to think about range, weight, charging speed, battery life, cost, fire safety, cold weather performance, and recycling.
Batteries are also becoming more important in the electric grid. Solar panels and wind turbines do not always produce electricity at the exact time people need it.
So, batteries can store energy when production is high and release it when demand rises or when production drops.
Yeah, grid batteries can also help stabilize the power system. They can respond quickly when supply and demand shift. That makes them very useful for backup power and the balancing and for balancing renewable energy.
Lithium ion batteries are common in many grid storage projects, but they are not the only option. Flow batteries, sodium sulfur batteries, and other designs are also used or under development for large scale storage.
Now, flow batteries are different from the batteries that most people see. Instead of storing all the energy inside a sealed cell, they use liquid electrolytes stored in tanks.
Yeah, if you saw one, you wouldn't recognize it as a battery. That
You
makes
probably
them
wouldn't even think it was anything close to a battery.
probably not. That makes them interesting for large stationary storage. If you want more capacity, you can use larger tanks. That's different from a phone battery where everything has to fit in a small package.
Flow batteries are not usually the answer for small portable devices. They are more relevant when space and weight are less important, long cycle life, and large storage capacity.
Yeah, let's turn our attention to solid state batteries. They are one of the major areas of current research and development. In a standard lithium ion battery, the electrolyte is usually liquid. In a solid state battery, the electrolyte is solid.
Well, the hope is that solid state designs may improve safety, increase energy density, and allow faster charging, but making them reliable, affordable, and easier to manufacture at this scale is difficult.
You know, Chandler, that's a pattern in battery history. A new battery idea may work in a laboratory long before it becomes a practical product. The challenge is not just chemistry, it is manufacturing, cost, safety, durability, and supply chains.
I got to say that this is a great example of why, Dr. Deneen, you're so valuable here. Because what you just said, I just want to reify it. You bring it to us. That's a pattern in battery history. Thank you for bringing that up.
You're very welcome.
Absolutely, Dr. Deneen. And one question that people often ask is why don't we just use the best battery for everything?
Well, because there's no single best battery. A battery for a smoke detector is judged differently from a battery for a pacemaker, a flashlight, a power drill, a submarine, or an electric car.
Engineers choose batteries based on trade-offs: energy density, power output, cost, rechargeability, shelf life, safety, size, weight, temperature range, and most importantly, environmental impact.
Now, a cheap alkaline battery may be perfect for a remote control. A lithium-ion battery may be better for a laptop. A lead-acid battery may still be useful for starting a car. A flow battery may make sense for stationary energy storage. So they all have their different uses for different things.
Yes, I love that you bring the practical side into things, Chandler. Thanks.
Well, you're welcome, and thank you, Dr. Weaver.
So, battery history is not a straight line when one invention simply replaces everything before it. Nope. Older battery types often survive because they still do certain kinds of jobs very well, as Chandler just pointed out for us.
Both of you are absolutely correct. Batteries change communication first through telegraphy and later through radios, telephones, laptop computers, and mobile phones.
They changed safety through flashlights, emergency lighting, smoke detectors, medical alarms, backup power systems, and affordable radios.
And portable radios, too, huh? They changed medicine through hearing aids, pacemakers, insulin pumps, surgical tools, patient monitors, and portable diagnostic equipment.
They change work through cordless drills, laptops, warehouse equipment, emergency systems, and portable measurement tools.
That's right. They changed transportation through starter batteries, hybrids, electric cars, electric scooters, electric bicycles, wheelchairs, forklifts, and drones.
And they changed everyday habits. People now expect devices to move with them. That expectation depends on batteries.
Batteries also bring problems. Some require mining materials such as lithium, cobalt, nickel, lead, and other metals. Mining can create environmental damage and labor concerns.
That's right, Dr. Deneen, and disposal is another issue. Some batteries contain toxic materials. Even batteries that are safer in normal use can cause fires or pollution if they're carelessly thrown away.
Yes, recycling matters, but battery recycling is complicated. Different chemistries require different processes. A lead acid battery is handled differently from a lithium ion battery.
There's also the issue of energy demand. As society uses more electric vehicles, more electronics, and more grid storage, battery production has to grow without creating a whole new set of environmental and social problems.
Yeah, and that's why researchers are working on alternatives such as sodium ion batteries, improved lithium ion designs, solid state batteries, and better recycling methods.
What batteries really represent is another kind of issue here. The battery began as a scientific answer to a question about electricity. Volta wanted to show that electricity could come from the contact of materials, not only from living tissue.
From there, the battery became a tool for communication, transportation, medicine, industry, and personal technology.
It's one of those inventions that hides in plain sight. It sits inside devices, under hoods, behind panels, in pockets, in hospitals, and in power systems.
The basic idea remains the same. Chemical energy is converted into electrical energy, but the uses have expanded far beyond anything the Volta could have imagined in 1800. That is for sure.
Absolutely. And that is precisely why batteries deserve attention. They did not just help scientists study electricity, they helped make electricity portable.
Yes, they did. And once electricity became portable, modern life started moving differently.
Absolutely. Listen, we could go on, but that's enough for this episode. I want to thank you for tuning in and listening.
Yeah, this was quite interesting. We hope that you've enjoyed this episode, and we hope that you've learned a little bit about batteries. Be sure to like, comment, subscribe, and come back and see us, folks. Bye
Goodbye
for
for
now.
now.